Okay, so let's take a look at a couple theorems, or corollaries rather. But this one talks about how when different inscribed angles have the same arc that subtends them. And so it says, if I read it, it says, if inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are congruent, right? So I'll just kind of trace these, right? But if you look at at angle ACB, so I'm going to just kind of trace over it, right? At angle ACB, you look maybe at angle ADB, okay? And then finally angle AEB, okay? This intercepted arc is the exact same on all of them. Okay, I'm going to switch to the orange that they have kind of going on here. But right, this intercepted arc, or arc AB, it subtends all of those different inscribed angles, right? So therefore, what we conclude is that the measure of all of these inscribed angles are the same, right? So they're actually really congruent, okay? And then one more that sort of follows here is that if an inscribed angle subtends a semicircle, if and only if the angle is a right angle, okay? And so an easy way to remember this is really just kind of the exact same stuff that we've been doing, okay? But really, again, this diameter here, it's a semicircle, okay? Meaning this arc is going to be 180 degrees, okay? And so really, if we just kind of follow the same rule, again, the measure of the inscribed angle is 1/2 of the intercepted arc, right? So if this is 180, half of that has to be 90, okay? So again, this is an example of a biconditional statement. I'll read it one more time, okay? An inscribed angle subtends a semicircle if and only if the angle is a right angle, okay? And so let's take a look at a few examples here where these theorems kind of come into play. All right, so this first one says we want to find the angle measures of inscribed triangles, okay? So again, that means the triangles are inside of the circles, right? Inscribed. So we want to find the value of A, okay? So what I see right away is the fact that this is a diameter, right? So I'm going to trace this in blue. Okay, so WY, or segment WY, is a diameter, okay? So that means the subtended arc, if we want to call it that, is going to be 180 degrees, right? It's half of 160 degrees, okay? And so what we kind of concluded from this is the fact that the measure of angle WZY has to be a right angle, okay? So again, this arc, it subtends a semicircle if and only if the measure of the inscribed angle is 90 degrees. So all I have to do here is just say that 5A plus 20 equals 90, okay? And I can subtract 20 from each side and get 5A equals 70 and find that my value of A is 14. Okay, so really as simple as that, okay? So if you see kind of an inscribed triangle and one of the sides is a diameter, okay, you'll see that particular theorem come into play, okay? Let's take a look at another one, okay? So on this one, we want to know the measure of angle LJM, okay? So I'm going to just draw a couple things here, right? So maybe LJM, I'm just going to trace it here. Okay, so I'm going to go L to J to M. Okay, and let's just kind of look at what else we actually know here, okay? So maybe I'm actually just going to see that it looks like this arc subtends another inscribed angle too, or we have like a common intercepted arc here, okay? And so it looks like, again, this arc LM subtends both of those inscribed angles. Therefore, those inscribed angles must actually have the same measure, okay? So what I'm just going to write down here is the fact that the measure of angle LJM must be equal to the measure of angle, actually I'll put this in blue, I think the colors kind of help here. So the measure of angle, we'll just call it MKL. Okay, and so now I'm just going to plug in everything here. So I'm just going to substitute the algebra, okay, or what they gave me here. So 5b minus 7 is going to be equal to 3b. And I'll just kind of solve the rest of this in black here. This should be pretty easy. Right, so I'm going to just subtract 3b from each side. I'll get 2b equals 7. And I'll find out that my value of b is about 3.5. Okay, that doesn't actually answer my question, but it is going to help. Okay, so again, we want to know the measure of angle LJM. So I'm just going to say the measure of angle LJM is going to be equal to 5 times 3.5 minus 7. Okay, and I'll just plug this into my calculator here. I'll get, again, 5 times 3.5. So 5 times 3.5 gives me 17.5. And 17.5 minus 7, we would find that the measure of angle LJM is going to be equal to 10.5 degrees. Okay, remember, don't forget your labels here. Don't forget to put degrees. Okay, let's look at just a couple more examples here in this video. I know it's getting a little long, but we'll survive. Okay, so let's look one more time. Again, we have an inscribed triangle here. We want to find the measure of Z. Okay, so again, I look at this right away. I see that this goes right through the center of the circle. X represents the center of the circle. And so AC represents a diameter, and this would represent a semicircle. Okay, semicircles have, again, that measure of 180 degrees. Okay, and so if that has a measure of 180 degrees, or that arc does, that means that the measure of the inscribed angle is half of that, right? So that must mean that this is a right angle. Okay, and so now all I have to do is just say that 8z minus 6 is going to be equal to 90 degrees. Okay, and I'll just do the algebra and solve this, right? I'll get 8z is going to be equal to, again, 90 plus 6 is just going to be 96, and I'll find out that my value for z is 12. Okay, moving on to one more example problem. Okay, again, we want to know now the measure of angle EDF. Okay, so I'm just going to use more colors here, right? So EDF is this inscribed angle right here. Again, I find it very helpful to use colors and trace. It helps you to see things a little better. Okay, I see kind of another inscribed angle here that's going to be subtended by that same arc. Okay, or this intercepted arc right here, which is arc EF. Okay, so again, if arc EF subtends both of those inscribed angles, that must mean that those inscribed angles are congruent. And so I'll just say now the measure of angle EDF is going to be equal to the measure of angle EGF. Okay, and now I'll just substitute the algebra here. So I can say that 2x plus 3 is going to be equal to 75 minus 2x. Okay, and I can just go ahead and use inverse operations to solve. So I'll end up getting like 4x is going to be equal to 72. 72 divided by 4 is going to be 18. Okay, remember, we did not answer the question yet. We want to know the measure of angle EDF, so I'll just say the measure of angle EDF is going to be equal to EDF 2 times 18 plus 3, and that will give us a total of 39 degrees. Okay. Again, I hope these are helpful to you guys. Again, I highly recommend using highlighters and colors so that you can see the pictures a little bit better.